important AQ type of an antenna here, which I think you people have come across this particular antenna physically also here in many of the uh, oh, homes. It will be there here. YagiUda array here. I think you have not this Doordarshan channel, previously used to have that antenna kind of a thing. Only DD1 used to come. No? That kind of an antenna here. Okay, so that is YagiUda. That antenna is called as YagiUda. You can see in this particular figure here. See here, it will be in the same kind. No, there will be one larger will be length, one larger rod length will be there, and then the second will be little bit shorter, and the third one will be little shorter. Like this, it goes on up to some 10 to 12 rods will be there here. Oh, that kind of antenna is nothing but here. You have seen this particular antenna at many of the house tops here, right? Okay. Nowadays, whatever the antennas we are having, dish TV antenna and everything, these are all dish antennas here, right? It will be called as a parabolic antenna here. Okay, whatever the antennas we are having, direct to home services there, that is parabolic antenna here. Now, usually in the previous days, we used to have this one antenna, DD1 Doordarshan used to come to broadcasting. That antenna is this YagiUda antenna here. Now, let us understand what is exactly terms we are having in this particular YagiUda array here. YagiUda array's name comes from the famous scientist here. Okay, Yagi is one person here, and Yuda is also one person who discovered this particular antenna specification, or you can say antenna structure here. Hence, it is been named after them here, YagiUda antenna here. Okay, now in this case here, we are having some passive and active element here. So passive element is one. I think you know this one here. Passive element is one for which there is no direct power supply here. So that is also called as a parasitic element here. Parasitic element is also known as a passive element here, to which power is not supplied directly here. Okay, so whichever the element there is a direct power supply here is called as active element here. Okay, or also you can say that driven element here. In this case, it is driven element here. Okay, remember two terms here, active and passive. I think you already know here, but now you need to understand them in terms of parasitic and driven element here. Parasitic is nothing but a passive element to which the power supply is not given directly. Driven element is a one here to which the power is supplied directly here. Okay, so let us understand the combination here. How many active elements will be there, and how many passive elements will be there in this YagiUda array here. YagiUda is a combination of one active element here. Remember, there is one active element, only one. Driven element you can consider here. Okay, so that is connected to either transmitter or receiver here with a transmission line, and there are number of additional parasitic elements will be connected here. Okay, okay. So usually, what are the additional parasitic elements that have been connected here to this YagiUda array? One is the reflector here. This is what larger in length here. The left side you can see this is what is your reflector element here. Okay, this is the driven element here to which the power supply has been connected here. See, you can see AC power supply has been given here. So this is what is a driven element here, and these, okay, on the right side, all these are called as directors here. Okay, so there is always in this particular structure only one driven element will be there, and there are n number of directors here based on the how much directivity we wanted to have. The number of directors can be increased here. Okay, and there is only one reflector element here. Remember, only one reflector element, only one driven element, and maybe based on the requirement, based on the how much directivity or the gain we wanted from the particular antenna here, we can increase the or decrease the number of directors connected to it here. Okay, so it is a combination of what here, one driven element, one reflector element, and as the application requires, that many directors we can add here, right? So this is what is YagiUda structure here. You can see here usually. And one more thing is, always remember here, reflector element is always taller, or you can say slightly larger than the driven element here. Always slightly larger, or you can say taller than the driven element here. Okay, And remember, all the directors will be always of the same always, or maybe they are of the same height here, or always less than the driven element here. Okay, lesser in height or shorter in height compared to the driven element here. Reflector element will be always taller or larger than the driven element. Okay, driven element is always, okay, larger or taller than the other directors here. Okay, directors are always shorter in length here comparable to the driven element and reflector element here. Okay, okay, this is how regarding the structure here concerned with the YagiUda array here. As you can see in this particular figure here, there are I mean n minus 2 directors have been connected. The spacing, or what you can say, that diameter or radius is nothing but here, radius is a here, diameter is 2a here, and the distance between the two directors is sn here. The length of the director is ln here. Okay, okay. Now we can see, mm, mm, the length of the parasitic element is always here. I just know whatever I have said here, same thing has been written in this sixth page number here. Whatever the parasitic element is there, always smaller than the feed element. Feed element is nothing but here driven element here, where exactly the power supply has been given here. Okay, that is nothing but here feed element here. So always smaller than the whatever the feed element is there in the direction of the beam here. Okay, and remember here, the length of the director should be about zero point 0.4 to 0.5 45 lambda here. Remember, length of the directors, whatever the directors we are having here now, 1 2 n minus 2 directors we are having, or n directors will be having. So all the lengths should be of what you can say 0.4 to 0.45 lambda here. Okay, and the length of the reflector is always greater than the feed here, and the spacing between, remember here, spacing between the driven element and the reflector element is always smaller here. Okay, and whatever the spacing between the driven element and the first director is also very small here, but uh, the space between the reflector and the driver element is much more smaller than the space between the driver element and the director element. That much you have to remember here. Okay, then what is exactly the characteristics here? What are the radiation characters here that are related to the YagiUda array antenna here? There are input impedance here, bandwidth is there, back to front ratio, magnitude of the minor lobes here, and backward and forward gain here. Okay, and remember here, whatever the lengths and diameters of the directors and reflectors are there, as well as the respective spacings are there, all these four things are there. No, that is either the length of the director, length of the reflector, or diameter of the director or diameter of the reflector is there. No, and corresponding spacing. These all things will determine the optimum characteristics of the particular YagiUda antenna here. Okay, uh, and remember here, these YagiUda antennas are having very low input impedance here, and also having the relatively very low bandwidth here. Okay, now if at all we wanted to have YagiUda can be summarized, that its performance can be considered in the three parts here. How exactly the performance of the YagiUda array can be judged here, based on the three things here. How exactly our driven element is there here. Okay, how much efficient our driven element is there here. How much the power supply has been given to that particular driven element here. That is one case here. And how exactly the reflector feeder arrangement is it. That means the space between the reflector and the driven element, or how much is the length of the reflector. If at all we have the length of the reflector as very small, or a little bit of small compared to the driven element, then there is a little bit of performance reduction will be there. So always remember, the reflector element should be greater than the whatever the feeder element here. Okay, or you can say driven element here. That's what you can say, reflector feeder arrangement here. Okay, that arrangement should be perfect here. And whatever the reflector and the driven space is there between the space, it should be always less than the driven element and the directors here. So that also we need to take into consideration. And the row of direct, how many directors are being considered here. Okay, so these three means whether we are having only the 4 to 5 directors, or we are having 10 tens of directors here. As I told in the previous initial stages here, the number of directors that has been attached here will indicate the directivity and the gain of the particular antenna here. That's why it is in the third point is mentioned the row of directors. How many directors we are going to connect here? Okay, reflector feeder arrangement. How exactly our feeder is there? That is nothing but the driver element here, and the number of directors that has been connected to the particular YagiUda structure here or arrangement here. Now, there are advantages that has been offered, and there are certain disadvantages that are also there in this particular antenna here. Antenna has gain which allows lower strength here, lower to be received here. Okay, and that is one of the advantage here. If at all we have a lower powered signals are there that has been transmitted here. Okay, so that could also be received here. Okay, and antenna, this particular antenna is having the directivity which minimizes the interference levels here. Okay, and it is also every I think I told you the initial of this YagiUda array discussion here. It is made up of rods here. Okay, how many rods have been connected? Director, okay, and the driven element and the reflector all are made up of some metallic rods only here. Okay, the construction enables the antenna to be mounted easily on vertical and other poles with standard mechanical fixing. I think it is very easy to carry out here, right? So you can see on every houses in some 10 years before, you would see that it has been arranged with mechanical help or something else here, right? Can be easily mounted on any of the houses here, very cheap to available in the market also here. Now, what are the disadvantages we are able to have here? Very high gain levels are there here. If at all it's become a very large area, as I said again, if at all you are going to have very long what you can say YagiUda array, that means we are adding more number of directors here. That means we'll be having the high gains here. There is some we need to have longer, length here. It is very difficult to easily fit on the your houses here if at all we have more number of directors here. So that's why bit big. If at all we wanted to achieve the more gains, means you have to attach more number of directors here. Bit difficult. And also gain limited to around 2 dB only here. These are the two disadvantages concerned with the YagiUda antenna here. Okay. So I think it is quite clear with this theoretical thing here, that is YagiUda array and horn antenna here. Remember here we are having, I think I have not discussed regarding the formulas concerned with the YagiUda array here. Okay, so only the theoretical content and the structure content I have discussed here, arrangement and disadvantages and advantages here. So whatever the problems are there here concerned with the YagiUda, it is very easy to understand also. So whatever the equations are there, we will discuss when we are going to discuss or when we are going to solve the problems here on the